Now it's time to perform an activity. Take a drawing paper. Now using the ruler, draw a line, say OA, on the paper. Using a protractor, draw lines OB, OC and OD, making an angle of 30 degree, 60 degree and 90 degree with the line OA respectively. Now take two mirrors. Place them along OA and OD such that they are perpendicular to each other. Place a lighted candle between the two mirrors. We can see that the images are formed in both the mirrors. How many images do we see? We see 3 images of the candle. Let us note down our observation in a table. Now let us change the angle between the mirrors. Shift the mirror placed on line OD to OC such that the angle between the mirrors is 60 degree. This time, how many images are seen? We see 5 images of candle. Next, shift the mirror placed on OC to OB such that the angle between two mirrors is 30 degree. This time we see 11 images of the candle. In the same way, if we keep two mirrors at an angle of 45 degree, then we get 7 images. And if we keep two mirrors at an angle of 120 degree, then we get 2 images of the candle. If we study the observations, we come to know that there is a relationship between measure of the angle and number of images. It is given by the formula n is equal to 360 degree upon a minus 1, where n is equal to number of images and a is equal to angle between the mirrors. Let us now check if the number of images obtained for different values of angle is consistent with this formula or not. If the angle between the mirrors is 90 degree, then the number of images formed will be 360 degree upon 90 degree minus 1, which is equal to 4 minus 1, which equals to 3. Thus, 3 images are formed when two mirrors are placed at an angle of 90 degree to each other. The number of images observed during an activity and the number of images obtained using the formula is equal. If the angle between the mirrors is 60 degree, then the number of images formed will be 360 degree upon 60 degree minus 1, which is equal to 6 minus 1, and that equals to 5. Thus, 5 images are formed when two mirrors are placed at an angle of 60 degree to each other. The number of images observed during an activity and the number of images obtained using the formula is equal. If the angle between the mirrors is 30 degree, then the number of images formed will be 360 degree upon 30 degree minus 1, which is equal to 12 minus 1, which equals to 11. Thus, 11 images are formed when two mirrors are placed at an angle of 30 degree to each other. The number of images observed during an activity and the number of images obtained using the formula is equal. In the same way, we can verify the number of images obtained when the angle between the two mirrors is 45 degree and 120 degree. Now, can you tell the number of images that will be obtained if an object is kept in between two mirrors that are parallel to each other? Yes, you are right. If the object is kept in between two mirrors that are kept parallel to each other, the number of images formed will be infinite. Let us now prove that in order to see the full image of a person standing in front of a plane mirror, the minimum height of the mirror must be half the height of the person. This can be proved with the help of a schematic diagram. Here, HF represents the person standing in front of a plane mirror PQ in such a way that PQ is parallel to HF. The mirror PQ is at a height of NQ from the ground and is perpendicular to it. H1 F1 represents the image of a person standing in front of the mirror. Points H, E and F correspond to the top of the head, eyes and the feet of the person respectively. Point R is the midpoint of HE and point S is the midpoint of EF. Incident ray HP gets reflected as PE. Similarly, incident ray FQ gets reflected as QE. PQ is the minimum height of the mirror in order to obtain the full image of the person. For this, RP and QS must be perpendicular to the mirror. Thus, minimum height of the mirror PQ is equal to RS, which is equal to RE plus ES. But RE is equal to HE upon 2 and ES is equal to EF upon 2. Substituting these values in the above equation, we get PQ is equal to HF upon 2, which is nothing but half the height of the person. This shows that in order to see the full image of a person standing in front of a mirror, the minimum height of the mirror must be half the height of the person. Come, let us now proceed to study about spherical mirrors.